Okay, so this is experiment 510. So this is the single tank discharge apparatus. And here's the control valve here on the bottom of the tank. And if you saw the video for experiment 520, the multi-tank discharge experiment, you'll notice that this is another manual valve that's on the discharge line of the tank. So basically, if the level gets too high and you can't control it, you can drain some of the water out. Plus, when you're calibrating the pressure transducer on the bottom, you can also use that to drain some of the water out. So what I'm going to do is I'm going to go ahead and put some water in this tank. Right now I got this valve open. Go ahead and close this valve here. And here's your water supply here. Turn this on. It goes to this rotometer, so I can start putting some water in here with the rotometer. And if you notice, right over here, this is a display for the differential pressure transducer signal. And as the level of water in the tank rises, so does the output of the sensor. Now, remember, the measurement sensor output is the input to the controller. So this is our controller here, and right now it's just set to monitor only. It's not going to provide any output. And what we're going to do is, for the first experiment, you are going to be the controller, and we're going to operate this system manually. So I'm just going to put some water in the tank. And what I want you to do, one of the things that you're going to need to do, is you're going to need to characterize the transducer output as a function of the water level height in the tank. And so, if I put some water in the tank, we'll let it settle there. And so, you can actually, this ruler that's on the side of the tank is in centimeters on this side, so you'll use centimeters. So you measure the centimeter height of water in the tank and also record the counts. The display is just in counts, which isn't any kind of engineering unit that you're going to use. However, the controller makes control decisions based on that. And I think it's important for us to anyways to start understanding what the controller sees and what it makes decisions on. So the controller, what it sees is the output of this transducer. So this transducer has an output that goes to the controller, and that's the signal the controller sees. Now there's going to be some set point. And the set point maybe is going to be some height in the tank. So let's say we want to control the height level of water in this tank to say 300 or 30 centimeters of water. So take this up to about 30 and see what the output on our transducer is. A little bit much. Oh, we got to do this a little bit. There we go. So, at 30 centimeters of height, it's reading 827 counts. And what we're going to do, too, is we're going to go ahead and power our control valve. This is our final control element. So, the input to the final control element is the output of the controller. And this is a power supply. It's already on. And it does two things. First thing it does, and this is a V1 and a V2, it has two channels. The first channel is at 10 volts already, and it provides power to our sensor in order for it to run. And V1 is the control signal, which you'll be able to read on a multimeter here. And so as I apply a signal, my valve starts to open up and get some fluid draining out. So, of course, the idea with level control is you're going to have some flow going into the tank and some flow going out, which you're going to have to balance in order to keep the level constant. Now, you can just see already that the level's rising, which means that the inflow is greater than the outflow. So that means that I need to send more power to my final control element. And so I'm pretty close now to having it balanced, it looks like. Maybe dropping a little bit. And so, of course, as that signal goes down, that means that the outflow from the valve is greater than the inflow going into the tank, which is, you read on the rotometer here. Now, one of the things you're going to be interested in knowing on this system is, does the height of water in the tank influence the flow that you can get through the control valve at a fixed input signal to the valve? So as you change, so let's say I set the power to one setting to the valve, and I can balance out the flow going in. And right now we got about 550. I'm going to change it to about 500 milliliters per minute, and you can read what the input power is going to the valve. And basically what we're seeing right now is that the level is starting to drop, which means our signal may be a little bit too high, so we can back off on that a little bit. But is that same input signal, let's say right now I've got it set to 15 volts, is that signal going to be the same at this flow rate at a different height of water in the tank? And that's something that you're going to investigate. So you're going to calibrate the pressure transducer, and you're also going to characterize the final control element. So those are the two main parts of the experiment 1 that you'll do with experiment 510.